Assalamu alaikum students. So our today's lesson is about problem solving and design. This is the very first chapter of paper 2 of computer science in O levels. Basically the paper 2 is based on programming, but this is the only chapter that contains some theoretical part related to the programming. Okay, so it is very important. I hope that you will enjoy today's lesson. So let's begin. Okay, when a problem is given to a programmer, so sometimes he faces different situations. One situation is shown here on this slide. Look at it. What are you working on? The programmer replies, trying to fix the problems I created when I tried to fix the problems I created when I tried to fix the problems I created. So it seems funny, but it is true. It really happens when the programmer starts working on any problem and he tries to find out the solution of that problem. And this chapter, the problem solving and design, is all about those problems. Those problems are the tasks given to the program. And the programmer designs a program that can deal that type of problem. Okay. It seems very difficult. It seems very boring sometimes when we get stuck at some point, when the programmer is stuck at some point and he is unable to find out the solution of that problem. But it takes little time when he works upon it and he finds out the solution of it. So the sense of achievement, it is greater than all the problems that he had faced while he was working upon. Okay, so let's begin. Our today's objectives are computer system and the subsystem. First of all, we'll discuss that what are the computer systems and what are the components of the computer system and what is mean by the subsystem. Then we will see the top-down designs, the structure diagrams, algorithms, pseudocodes, flowchart, library routines, and the subroutines. Okay, so that is the very first topic, today's topic. What is a computer system? If someone asks you that what is a computer system, whenever I ask this question to my students, usually they answer that the computer system is a computer system is a device. It's an electronic machine, and that works on our instructions and gives us the solution. Absolutely right. But when you are whenever you are giving this definition, so you are just explaining the working of computer or device, not a whole computer system. The whole computer system is quite big. Okay, it is not about the device only. Okay, let's see that what are the things, what are the components of a computer system. Actually, the computer system is what? The computer system takes data, it processes that data and gives us the outcome, the result. Okay, that is the main computer system. But again, I'm not explaining the device. I am talking about a whole system. So let's see that what are the components, the basic components of a computer system. The very first thing is a software. Softwares are essential in all the computer systems. If there are no softwares, so means we are unable, if there are no softwares, we cannot process the data. To process the data, we need some softwares. The second thing is the hardware. That in our computer system, what kind of hardwares will be used. Okay, it depends on our requirement, and that when the requirement varies, the hardware varies. Okay, so all the instruments, devices that are going to be used in a computer system, they will come they will fall in this category. Okay. The third thing is communication. Usually when the students start explaining about the computer system, so they usually forget this thing, the communication, and it is very, very important thing in a communication in a computer system. The communication can be internal communication, means from one device to another in a computer system, or it can be external communication from external device to the computer. Okay, you can understand this from the example. For example, if you go to um, bank ATM machine and you just use your card and take out some money from that ATM machine, it is not necessary that you are using the same ATM that is installed in that branch where you have your account. Okay, maybe your branch is different and the ATM machine is installed somewhere else. So there will be the communication, and that communication will be used. And what hardwares are going to be used at that time? That machine where you are going to insert your card, that keypad, the screen from where you are giving the instructions, and at the back end there is some sort of software. Okay, the communication is from that machine, that ATM machine, to your branch, the hardware that you are using and the software that is working at the back end. Okay, so let's move further. The next component of a computer system, it is data. Data is also very important. Without the data, the computer system doesn't exist, it doesn't work. If the main purpose of computer system is what? It is the same. The computer system is the one that takes data, it processes that data and gives you the result. If we don't have we don't have data, so we do not need a computer system. Okay, and the last and the most important ones are people. Those people who are operating that computer system, who are working on that computer system, a computer software engineer who designed that software, who found, who solved all the problems in that system. These are the peoples who decide that what kind of hardware is going to be used in it. And the people are the ones who set up the whole system. And the people are the one who use that system. Okay. So I hope that you must have understood what is mean by the computer system. So a computer system is made up of software, data, hardware, communication, and people. Okay, remember, if the question comes in the examination, don't forget these two things, communication and people. As I told you earlier, mostly students forget these two things and they think that the software, data, hardware, only these things make the computer system. No, we have all these five components. When we have all these five components, then we have a computer system. Okay, so when we have a computer system can be a big or can be a small, and it is a bit complicated. It can be very difficult to understand the whole computer system, but we have a solution of it. And what is that solution? Each computer system can be divided up into a set of subsystems. Subsystems are the smaller systems, are the part of that main computer system. Okay, uh, so they are the set of, a computer system is a set of subsystems. Means in a computer system, maybe there are several subsystems. Okay, and each subsystem can be further divided into subsystems, and so on until each subsystem just performs a single action. If we start dividing our computer system into the subsystem and we keeps on divided until we find we have one system that is only performing one action, so we can easily understand, with the help of this technique, we can understand the whole computer system. Okay, this point will be clear ahead in the same class, so no need to worry about if there are any confusions. Okay, if you have any queries about computer systems, so you can ask questions. Okay, we are moving further right now. Okay, the second topic is about top-down designs and the structure diagrams. What are these top-down designs and the structure diagrams? They are commonly used terms in the computer science. So a top-down approach is essentially the breaking down of a system to gain insight into the subsystem that make it up. As I told you in the previous slide, to understand the main computer system, there is a technique in which we divide the computer system into the subsystems, and we keep on dividing it until we have one system that is only doing one action. Okay, so this technique is called the top-down design. Okay, so top-down design is basically a splitting up or breaking down or dividing of a computer system just to understand that what is happening in a subsystems. If we understand the subsystems, we will understand the whole computer system. Okay, so the second thing is a structure diagram. It is interconnected with the top-down design. Actually, what it is, if you have understood the top-down design, so it is very easy for you to understand the structure diagram. A structure diagram is a pictorial representation of top-down design. Okay, the structure diagram shows the design of a computer system in a hierarchical way. Okay, means from top we write the main computer system, what it is, and then the subsystems of it, and then the subsystem of a subsystem, and we keep on doing it until we have one subsystem that is doing one action. So when we present this thing in a form of a diagram, so it is called a structure diagram, and that structure diagram is actually a structure of our whole computer system. Okay, I hope that you must have understood about the top-down design and the structure diagrams. So we are moving further. In this slide, you will understand the structure diagram more easily. Let's see that what is happening. For example, if we are given a problem in which we need to create software that will take temperature as input, and whatever we will give the input, it will convert it into the different unit. For example, if we have given the centigrade, so it will give us Fahrenheit. If we have given the Fahrenheit, so it will give us centigrade. Okay, so that is a computer system that we are going to create. What can be the subsystems of it? So first of all, we will see that the temperature conversion can be done in two different ways. And what are those? One from Fahrenheit to centigrade, the second one is centigrade to Fahrenheit. And if we are going to work on this one, that Fahrenheit to centigrade, so what will be the subsystems of this subsystem and what will be the subsystems of this one? So you can, okay, let's see. We have two more subsystems. One says input Fahrenheit, the second one says convert and output centigrade. Okay, in the same way, here we have input centigrade and it will be converted and output the Fahrenheit. Okay, these are the subsystems of the previous one, and these were the subsystems of the main computer system. So in this way, we can understand what is going on in this main computer system. Okay, if I ask you at this point that what will be the subsystems of this input Fahrenheit, do you think that it can be divided into the subsystem? It depends on the requirement. Okay, for example, we don't know that how the input will be given. Maybe the input is going to be given by the sensor, by the heat temperature, as we have already studied in the uh, input output devices, that the sensors are used to give the inputs. Okay, so this can be one subsystem. And what is that? Sensors. And what will be the other way of giving the input? Yes, the input can be given by human, manual input. If the input is given manually, so they can be two subsystems of input Fahrenheit. Okay, if we have sensors, so of course it will be having some more subsystems. Okay, I hope that now you must have understood what is the top-down design and what is the structure diagram, what is a computer system, and what are the subsystems. Okay, so that was the computer system. They all are the subsystems of this computer system. Okay, so let's move further. Okay, the next topic is algorithm. What is algorithm? An algorithm is a procedure or formula for solving a problem based on conducting a sequence of specified actions. Okay, means we are not going to tell that how the problems will be solved. Okay, we will also be telling that what is needed, what is going to be done, and we will also tell that how that thing is going to be done, both the things. Okay, an algorithm is the set of instructions that defines not just what needs to be done but how to do it, and it has two standard forms. One is pseudocode, the second one is flowchart. So you can understand that what is an algorithm. Algorithm is the step-by-step solution of any problem. And the problem is the task, as we have discussed earlier. Okay. So let's see that what are the pseudocodes. Pseudocodes are actually written in the informal language, informal high-level language. The high-level languages are the ones that the human can understand. I'm not talking about the programming language. I'm talking about the high-level language. Okay, it contains description and the solution of a problem, but the step by step, as we have discussed earlier, that the algorithm and the pseudocode is a type of algorithm. So don't go away from that point, that the algorithm is the step by step solution of any problem. So in the pseudocode, we will be using simple language in which we will tell that what is going to be done and how it is going to be done in the form of steps, and we will be using informal language. Okay, these are the English codes and they are very easy to understand. The programming codes are different. Okay, for the programming codes, we need to be focused and we need to remember that what will be the syntax of writing any command, any instruction. But in the pseudocode, we are not going to focus on those things. We just focus that what the problem is and how that problem can be solved. Okay, it is written in a symbolic code which must be translated into a programming language before it can be executed. It is very important point. Some students get confused in it, that they think that if they write the pseudocode in any interpreter and they try to execute it, so it will run the program. No, it will not run the program. If we want to run a program, we want to write a program, so we will be using programming language, and that is different than the pseudocodes. Okay, for example, if we have a problem in which the problem says that find the sum of two integers. That is a simple problem. Okay, just to explain you that what happens in the pseudocode. There is a pseudocode given of this problem. From here we are starting our pseudocode. The very first thing, input number 1 and number 2. As we discussed here, the sum of two integers. Okay, so we are taking two inputs first, number 1, number 2. When we have received these two, what will we do? We will add both of them, number 1 and number 2. We will add them together and then we will save it in one value, that will be the total, and we will output the total. As we discussed, that the algorithm is the step-by-step solution of the problem. So that was the problem and these are the steps how this problem can be resolved. If we just interchange the places of these two, or these two, or these two, any of them, so it will not work as it should work. For example, if this statement is written first and that the input is written afterward, so what will happen? Do you think that it will work? No, it will not work, because there isn't any value in number one. We have not taken input. There is no any value in number two. If we don't have the values, we cannot add them. Okay, so it is necessary to take the input first and then we are going to add them together and then we will give the output. Okay, these are the steps and how we dealt with this problem. Okay, so let's move further. The second standard form of algorithm, flowchart. A flowchart can be defined as a diagrammatic representation of an algorithm. As we were giving the codes or the English language terms we were using to explain the steps in the pseudocode, in the same way in flowchart, we use different symbols to show those steps. Okay, a step-by-step approach to solving a task. Okay, a flowchart can be defined as a diagrammatic representation of an algorithm, a step-by-step approach to solving a task. As we discussed, as we have seen it in the previous slide, let's see that what is happening here. We have the same problem. We have to take two integers and we are going to add them. So let's see that we are starting our algorithm from this point. But as you see that the command is written in one specific type of diagram, a symbol. We have oval here. And then we are taking input number one and number two. But as you see that we have a different symbol here. We were using oval to show the start, the beginning of the flowchart. And we are using parallelogram to show the input. Okay, the first is we start it, we take the input, and then we do the total. Total is equal to number one plus number two. It is some sort of process. The process is going on. So we show process in the rectangle. Now see, we are using the different symbols, different diagram, but we are showing the same steps. And at the end, we are giving the output and total. And it is again, we are using again the same parallelogram. These are the same steps as we have discussed earlier in the previous slide on the pseudocode. But when we represent them in the form of a diagram, so it is called a flowchart. Okay, so by now what we have understood, what are the computer systems, subsystems, what is mean by the top-down design, what are the structure diagrams, algorithm, pseudocodes, and the flowchart. And do not confuse between the top-down design and flowchart or structure diagram and a flowchart, because the flowchart gives you the step-by-step solution of a problem, whereas the structure diagram tells us that what are the subsystems of a main computer system. They both are different from one another. Okay, so let's move further. Library routines, a very commonly used term in the programming in a computer science. What are the library routines? A library routine is a debug block of code. Debug means where we do not have any type of errors, or whatever the errors were there, they have been resolved. Those issues have been resolved. Okay, it is a code that is saved in our program memory. Okay, our library routine is a debug block of code. It can be called a subroutine, it can be a procedure, it can be a function. Okay, procedure and the function are the different type of library routines, often designed to handle commonly occurring problems or tasks. The library routines are designed for what? The common problems that the programmers usually face while they are doing programming. Okay, for example, if I have a list of names and I want to ascend, if I want to arrange them in ascending order or descending order. And this type of requirement we can face at multiple times. Again and again we face this type of issue. Okay, we need to arrange a list into ascending or descending order. So it is better if we have this code that is going to arrange that list in an order. If we have that code stored in our library, so what will happen, we can call that code whenever we need it. We can call it, we will not be writing the whole code, we will be just calling it in our program because it is already stored, and whenever we use it, it performs the same task that is defined in the code of that library routine. Okay, this allows them to be called into immediate use when needed, even from other programs. Once you have created a code, it is stored in a library routine, it can be used in any program. Okay, so what will happen, the programmer will be able to save his time. And if the common problem is there, so we will not be writing the whole code again and again. Maybe there is a code of 100 lines or 50 lines. So isn't it better to just call it in our program rather than writing the whole 100 lines again? Okay, so the library routines are the procedures, are the functions that are already stored in our program library, and they can be called again and again in our program and whenever we need them. Okay, let's move further. What are the subroutines? A subroutine is a sequence of program instruction that performs a specific task packaged as a unit. They're just like the library routines, but what is the difference? The library routines are already available in our library. We just need to call them. Whereas subroutines, we write the code, and once we have written, we can save it. And then whenever we will be needing it, we can call it in the program. Okay, so the subroutine is a sequence of programming instructions that performs a specific task. Okay, it is just like the library routines, but there is a difference. Subroutines are not stored in our main library program. Library routines are already available in the library program. Okay, that is the main difference, but they are somehow same. Okay, so let's review that what we have studied today. Computer system. Computer system made up of software, hardware, data, communication, and people. Okay, top-down design is the breaking down of computer system into a set of subsystems. A structure diagram is a diagrammatic form of top-down design. Algorithm is a step-by-step process of a problem-solving solution. Okay, pseudocode describes what an algorithm does by using English keywords that are very similar to the high-level programming language. But remember, the high-level codes are different, language codes are different, pseudocodes are different. Flowchart describes what an algorithm does by using a standard set of symbols. Okay, we use a pictorial representation of an algorithm. Okay, library routines stored set of programming instructions for a given task that is already available to use, and where it is available in a program library. And the subroutines are the set of programming instruction for a given task that form a subsystem, not the whole program. Okay, not the whole computer system, but a subsystem. Okay, so that was our today's lesson. I have created a small quiz for you. I'm sharing this code in a chat box and you will be answering it. Thank you very much.